when we came up with the idea of teaching a critical thinking workshop, we intimidated ourselves a little bit, because critical thinking is enormous, and so is math. You could write several textbooks on both of those subjects individually, so how in the world are we going to cover them in 3 hours? And we really can't cover it comprehensively, but we figured we could get a good start by highlighting 3 of the things that we think are most important when it comes to teaching critical thinking in a math classroom. So the first thing that we're going to talk about is how you target skills in your classroom. How do you figure out what skills your students need to know, and how do you teach them deeply in the time limit in which your students will stay in your class? And then the context and the depth of knowledge, how do you frame the skills that you've taught in your classroom? How can you frame the skills in a way that helps your students abstract and generalize the concepts, that help your students relate them to their everyday lives, that help your students think in several different ways about the same concept? And then finally, evaluation. How do you assess what your students have learned? Particularly if you're trying to teach them critical thinking skills, how do you assess their critical thinking? That can be a little bit tricky. And then if we have time at the end, which I hope we will, we'll kind of wrap up, have questions and comments. And we want you guys to participate throughout, give us your ideas, your resources, your skills, so that we're all benefiting from each other. All right, does anybody have questions about the agenda before we dive right in? All right, fabulous. So, we're going to get started with our first section, which is about scaffolding. How you target the skills, how you figure out what you're going to teach, but teach it throughout the curriculum. And I know this workshop is focused on the new GED test primarily. There are some of you in this room that don't teach to the GED, but we think this is universal, because math is math, is math, is math, wherever you go. So, one of the things that we've noticed about the new GED test, that a lot of you probably have as well, is that it involves a whole lot more of the higher order thinking skills and a whole lot more of algebra. And if you teach in a linear fashion, where you start with whole numbers, then decimals, then fractions, then percents, and you keep building, by the time you finally get to algebra, you've probably lost like 2/3 of your class to attrition. And they've probably forgotten about half of what you taught them in the first term. And then you end up having to go over things over and over and over again. Is anybody familiar with this scenario? This happened to me. So we're going to talk a little bit about how you can structure your curriculum to incorporate those higher level thinking skills lowly in the curriculum, even at the beginning levels. So we're going to start out, does this question look familiar to anybody? Mm-hmm. It is a question from the GED item sampler. Oh, you're it's a question from the GED item sampler that involves a lot of skills in one, both basic skills and higher level skills. Do any of you have a class of students that could look at this question right now and answer it correctly? Maybe 1 or 2, but it's a hard question, right? It's a very hard question. So what we're going to do is take a look at this question and use it to model how we break down the skills and build on those skills to get your students to be able to solve it when they're faced with this. First of all, let's talk about solving it, because I want to make sure everybody knows how to solve it before we ask our students to solve it. So let's take a look at this problem. Can I have a volunteer to read it for me?
A scientist is studying red maple tree growth in a state park. She measured the trunk diameters of a sample of trees in the same month every other year. The tables show the data for 2 of the trees. I will not read the whole table.
Thank you.
This is the final year in which she will collect data. When her data collection is complete, she'll predict future red maple tree growth. In year 13, the scientist will put tree wrap around tree 1 to protect it from the winter snow. The height of the tree wrap needs to be 45 inches. The wrap is priced by the square foot. To the nearest square foot, how many square feet of wrap does she need?
All right. So when looking at this problem, what's our first step?